Hello chemistry students. We're going to learn today about solubility in this third video, and I want you to take a look at your notes on page 3 of 6, and we're going to fill in this first part using these 3 different illustrations. So we're going to talk about how a solution can be unsaturated, it can be saturated, or it can be supersaturated. And there's some key words that you have to remember about each one. And we can use hot tea as an example for all of these. So for example, if you use hot tea, if you like hot tea, and you want to sweeten it, you're going to add sugar. So how can you tell if it's unsaturated? Well, it's not going to be very sweet. So that solution contains less dissolved solute than the maximum amount at a given temperature. Okay, so it's not really sweet. So we can dissolve more. So that would be an unsaturated solution, and if you take a look right here, you might want to draw this little graphic where you have the molecules showing that there's a lot more that could be put in there. Now here we have a heated solution. We can talk about that hot tea again. Well, it looks heated, may not be, but we could still heat it up. And so how could we tell if it was the maximum amount of solute in hot tea? Well, it would be just right. It would be sweet. So when a solution contains the maximum amount of dissolved solute at a given temperature, let's just say it's warm, hot tea, yum, no more can be dissolved. You can't get any more sweet tea ever. You can't get any more sugar in that solution before you see something happening to it. And I bet if you've ever used sugar, you may have seen this. Sometimes our solutions can become supersaturated. So if we take that same hot tea and we continue to add more and more and more and more sugar to it, it would gradually fall, the sugar would fall out of the solution and fall right to the bottom of the cup. And so this would be an unstable solution. This type of solution contains more than the maximum amount of solute at a given temperature, and it will crystallize out of the solution. The sugar will literally just come out of the tea and form large crystals if it is supersaturated. So there's the difference between those 3 different states. Here's another way to look at it, and you have some test tubes. Test tubes can always show us what happens at the molecular level. So if you can imagine the molecules in here, you don't see any, right? Well, it's because we need to put some in there. So this is an unsaturated solution. It means that more solute dissolves. Here we have next a saturated solution. We can't get any more solute in here. Nothing else will dissolve because it's saturated. It's full. And then here we have a picture of the molecular level of a supersaturated solution. This becomes unstable because there's so much solute in it, and it starts to crystallize out. And so you're able to see these molecules with the naked eye because they start to form crystalline structures, and they can get pretty large if this happens. Okay, so in science, we use models, and this is a solubility curve. Okay, solubility curve. Let's talk about how we can use this curve to solve some problems. So we have on the dependent variable, as our dependent variable, the solubility. Well, what does the solubility depend on? The temperature. All right. So we can look at several different things. We've got some calcium chloride, we've got some potassium chloride, we've got potassium chlorate, we've got sodium chloride, and we've got something called cerium 3 sulfate. All right, so let's remember some things here. Number 1, any amount of solute below these lines, okay, of these different substances indicates that the solution is unsaturated at that temperature. All right, number 2, any amount of solute above the line in which all the solute has dissolved is going to be supersaturated. And if the amount of solute is above the line but not all has dissolved, the solution is saturated and the extra grams have precipitated or settled to the bottom. So we can plug that into our little formula, which says the number of grams that are precipitated can be calculated by subtracting the total number of grams in the solution by the total number of grams of solution, saturated solution, at that temperature. So we're actually going to do some of those problems. All right. So let's take the same graphic and see what we can figure out about it. So let's answer question number 1. Which substance maintains almost constant solubility over the temperature range? Take a look at your curves over here and see if your eye can find one that looks pretty much the same temperature and solubility relationship. It would be the NaCl, right? This green line doesn't change. The amount of solute seems to stay very consistent, no matter if you heat it up or not. You heat it up, it increases a little bit, but not so much. So, not as much as those others. So, sodium chloride has a pretty steady solubility range. Alright, number 2, which substance decreases in solubility? Take a look at the lines. And which one do you think decreases in solubility? Well, if you answered our nice little CeSO4, you would be correct. So cerium sulfate. Number 3, what is the solubility of potassium chlorate at 60 degrees Celsius? So let's just look at our 60 degrees Celsius and look at how many lines we have that are crossing this solubility line. So we're going to just look at the relationship between the solubility and we're going to look at the temperature. But first we want to find calcium chlorate, and there it is. So it's this purple line right here. And 60 degrees, there it is. At 60 degrees for our potassium chlorate, looks to me like we can get about 20 grams if we heat that up. So 20 grams. Number 4, a solution containing 50 grams of calcium chloride in 100 grams of water is being prepared at 10 degrees Celsius. Is the solution saturated, unsaturated, or supersaturated? So find calcium chloride. It's this red line up here. And then we want to look at our 10 degrees Celsius. Let's just find the temperature. So anything under this red line is going to be what? It's going to be unsaturated, right? So this is supersaturated. This is unsaturated. So we're preparing this 50 gram solution at 10 degrees Celsius. It looks to me like it's under that line. So that must mean that it is an unsaturated solution, right? Number 5, a supersaturated solution at 10 degrees Celsius contains 40 grams of potassium chloride in 100 grams of water. At what temperature was the solution saturated before being cooled to 10 degrees Celsius? So we have this solution, and we need to find it first. Potassium chloride, it's this orange line, and it contains 40 grams of solute. So this one contains 40 grams of solute. So here we have 40 grams. Let's see where it meets that line. Oh, there it is. At what temperature was the solution saturated before being cooled to 10 degrees? So let's just say it was cooled off to 10 degrees, okay, and we want to look at where it was saturated before it was cooled. And here it is. At 40 degrees, we have the saturation point right here. So your answer to this one is 40 degrees Celsius. All right, then for the last one, we're going to use, sorry about that, we're going to use our little equation. We said the number of grams that precipitated equal the total number of grams in solution less the number of saturated grams. So we're going to use that particular equation to sort of look at the last potassium chloride's problem. So if that supersaturated solution in the previous question, okay, is disturbed, how many grams of potassium chloride will fall out of the solution? So here we want the total number of grams that's going to fall out. So we're going to take the total number in the solution at 40 degrees, okay, and we see here that right about in here we get, you come in here with our 36 grams, it looks to me like. Yeah, it's about 36 grams that will plug in. That is a 3, y'all. And the 36 grams represents the number of saturated grams in the solution. So if we subtract these, we will get 4 grams of solute at the bottom of our beaker or whatever we are heating up. Alright, well, I hope you've enjoyed this. Play it back if you need to. Make sure you get all the information. Thanks, and see you next time.